Welcome back to the Scotti-BYTE channel, and this is Scott. So today I wanted to talk about the kernel virtual machine command line interface. In my last tutorial, KVM Virtual Machines 101, we learned how to create a VM using the GUI program virt-manager. I emphasize learning the command line interface for LXD and Docker on the channel, and so the KVM CLI is also a valuable tool to learn. In this tutorial, we'll learn how to use the command line to create a new virtual machine with virt-install. And we're going to also use the virsh command to manage virtual machines. So let's go see how to do this. Here we are at the command line prompt for my KVM host, and in the way of review, we're going to do an ifconfig command, and we'll notice that we have quite a few network devices here, but my physical network device is EMP4S0, and you can see that it is not granted an IP address. Instead, I have a device called bridge0, which is a bridge that gains my IP address, and this is valuable for my Docker containers, my LXD containers, and my KVM containers that I might want to present out onto my main LAN. So again, in the way of review, what we're going to do that is we're going to move over to etc/netplan, and once we move over to that folder, you'll usually see at least one YAML file, and you can go ahead and edit that, or you can create one if one does not currently exist. And a very simple bridge for your network might look like this. It would be network, and I have version 2. Renderer is network manager, and then Ethernets, I'm saying bridge 0, and I'm just giving the name servers and the addresses, and that was really all there was to it. And if you want to see in depth how I actually accomplished that bridge, you can watch some of my other videos where I go into depth on that. So assuming I was just creating my bridge, I would of course do a sudo netplan apply, and that would go ahead and make the changes that you've seen. And of course, I'll have these in the notes, but again, I would refer you back to previous videos where I talk about creating a bridge device. Assuming you've already watched the last video and you have installed KVM and also added yourself to the KVM and the LibVirt groups, you're all prepared to create a KVM VM from the command line, just like we did from virt-manager. And here's a very simple command to do exactly that. I do a sudo virt-install, and then --name equals ubuntu-test, because that's going to be the name of my server. I have a description field that simply says test server. My variant is, OS variant is Ubuntu 22.04. I'm giving it 2 virtual CPUs. I'm giving it 4 gigs of RAM. And then the path to my disk drive is going to be /var/libvirt/images/ubuntu-server.qcal2. So this path is normally where these things are stored in /var/lib/libvirt/images, and I'm giving it a disk name. That is, it emulates a disk inside of this file. And I'm saying use the compression format qcal2, and then I'm using bus driver virt.io because it's faster, and then I'm setting the disk up to be 15 gigabytes. And then I'm saying the user interface will be VNC, and then I'm pointing to a CD-ROM that happens to be out on my system, and this is a CD-ROM for the Ubuntu 2204 live server configuration, and we have our network pointing to the bridge device that we created in earlier videos, and I just basically reviewed a while ago. And Now, when I hit return, it goes off and it starts up a screen up here. I go ahead and hit enter, and this is installing a server. And the first question we have is, what language do we want? I'll hit enter on English. I'll say update to the new installer because that always makes things better. In this particular case, I'm going to stick with the English layout of the keyboard and the English variant. So I hit enter, and I'm going to be installing Ubuntu Server. I hit enter, and it's going to use DHCP. That's fine. Of course, I could statically address, but I'm going to just do this. I don't have a proxy server. I'm hitting that, and I'm going to do done on the mirror address, and I'm going to say use the entire disk. The entire 15 gigabytes that we reserved for this particular machine. And then the way the mount points are set up for the disks are fine, so I'll do a done. And it says, do you really want to continue? And it says it'll result in loss of data if you continue. Well, it thinks it's a physical hard disk. So of course I say continue. I'm going to type in my name as Scott, my server's name as Ubuntu-test. I'm going to give it a username of Scott, and I'm going to give it a password and confirm my password. And then I'm going to say, yes, I do want an SSH server. I'm going to do it done, and I could come down here installing the server and install any other components I want, but I'm just going to do done. Now that the installation's completed, I can tab down to reboot now and hit enter. You'll generally get a failed on-mounting CD-ROM because it can't really physically on-mount it. At this point, you hit your enter key again, and it will continue with the reboot. It will bring VirtViewer back up again, and it will boot the virtual machine, which is a Ubuntu 22.04 server, so it doesn't have a GUI, but we'll be able to see a login prompt as soon as the startup completes. Now that our installation is completed, I can SSH over to 172.16.1.223, which is the address that the virtual machine got. I say yes to the fingerprint, and I type in my password, and I'm logged into the virtual machine. Now you'll notice here in the background, when we exited the graphical console in the VirtViewer the first time, which was related to the fact that the installation was completed and it went through its first reboot, it went back into VirtViewer again, and when I exited VirtViewer, it came back to the command prompt on this system. So in the way of review, we can come back here to the host and we can paste in the command virtViewer -- connect QEMU : //system, and I say wait for Ubuntu test, and that will bring up the command prompt for Ubuntu test on the console, which I logged into just a while ago to find out the IP address. Of course, I can exit and log out of it, and we're on the console here. If I exit this and say OK, it will come back to the prompt. But up here, we're logged in to an SSH session. So in our SSH session, let's try to do a couple of things. Let's do an ifconfig, and we notice that we don't have NetTools installed, so let's install NetTools with a sudo apt install net-tools. And likewise, we probably also do not have neofetch installed. And while I'm thinking about it, let's do a sudo apt update && sudo apt upgrade, which is always good to do when you have a new system, -Y, and it will go ahead and perform all the necessary upgrades. So I'm performing updates on this machine simply so that we can have something to take a snapshot of. And one of the things that I think I'm going to do is I'm going to install Nala, N-A-L-A. If you haven't seen Nala, Nala is a front end to APT that provides some really great added value and improves the package installer in Debian operating systems like Ubuntu. So I'll have these in the show notes, but basically what I'm doing here is I'm installing Nala and getting it configured. Now that Nala is installed, here we can do a sudo Nala update. And you can see that that looks really good, and we can also do an upgrade. Of course, there's nothing to upgrade right now. If y'all are interested, I will do a video on Nala, but it was just something to install so we can look at the changes to the system. So now we have NetTools and we have Nala installed. So now I'm going to log off of my SSH session, and I'm going to go back to the host here, move ourselves back over to the home directory with a cd tilde. One of the really valuable KVM command line commands is virsh, and if we do a virsh list, here you can see the Ubuntu test server that we just created and is up and running. But if we do the virsh list space -- all, it will list the KVM machines, whether they're up or running or not. And you can see that I have two machines there that are shut down, the Ubuntu desktop and the Win11-QEMU, which I created as a part of previous videos. We also have the ability to shut down a running VM with the command virsh shutdown, and in this case, Ubuntu-test. It says it is being shut down, and if we do the virsh list -- all, you can see that all three machines are now shut down. Now that the virtual machine is shut down, we can perform a backup of it by doing a virsh dump xml ubuntu-test, and we're redirecting that to ubuntu-test.xml. Now it's created that file, and we can do a nano ubuntu-test.xml to see what the contents are. And basically, it gives you all the information necessary to build the virtual machine. Now, what this does not do, it does not create the hard drive. The hard drive is that separate image that we learned about earlier. To see where the hard drive image is actually stored, I'm doing a sudo ls al to /var/lib/libvirt/images. And you can see here that there is the ubuntu-server.qcow2. And that is the file that stores the contents of the hard drive. And that, along with the XML file, comprises the virtual machine. So I could delete this virtual machine by doing a virsh undefined ubuntu-test. And it says it's been undefined. Now, if we go up here and we do a virsh list -- all, you'll see that there's only the two virtual machines and not the server that we just created. However, if I look at the contents of the directory where the images for the hard drives are stored for KVM, you can see that I still have the server listed in this particular location. So if you've noticed very carefully, you probably noticed that my disk name is ubuntu-server.qcow2, yet the name of my server was ubuntu-test. And that's okay because the dump file that I created was ubuntu-test.xml, and the virsh define ubuntu.test.xml file is been loaded and redefined it. So I can do a virsh list --all, and you'll see that ubuntu-test is back. So the opposite of the virsh shutdown command is the virsh start ubuntu-test. And now it says it started, and so we should be able to do a virsh list --all, and we can see that the Ubuntu test is running. And now we can SSH back into that machine with an SSH 172.16.1.223, provide my password, and we're logged in. We can do an ifconfig, and we can see that net-tools is installed, and we can also do a sudo nala update, and we can see that nala is still on the system as well. And let's go ahead and exit out of this machine. And even though the machine is running, we can perform a snapshot with the command virsh create or snapshot-create-as ubuntu-test, and I'm going to call the snapshot initial-install. It performed the snapshot, and we can look and see which snapshots we have on that machine with the command virsh snapshot-list ubuntu-test. And you can see that it's up and running, and it says there was an initial install snapshot that was taken. Now let's log back into the virtual machine once again. And let's do a sudo apt install. Well, first of all, let's do a neofetch. And neofetch is not a currently installed command, so let's do a sudo apt install, or better yet, let's do a sudo nala install neofetch. And we give our password. And nala comes back and tells us a summary and says, do you want to continue? It gives us all of the updated elements, and it goes and performs the download and the installation. You can see that nala really is a nice front end to the apt package manager. Now that nala has installed neofetch, it tells us that a reboot is required, so we'll do a sudo reboot and reboot our virtual machine. And we log back into our virtual machine again, and this time we do a neofetch command to make sure that it's there, and there it is. So now we're going to exit out, and now we're going to do another snapshot, and this time we're going to call this snapshot added neofetch. It performs that snapshot, and we go do a snapshot list, and you can see that there are two snapshots, one called added neofetch and the other called initial install. Now what we're going to do is we're going to restore the initial snapshot with the virsh snapshot-revert ubuntu-test initial install. And now that it's signed back on, we'll do a neofetch, and you can see that neofetch is not installed. So we could exit back out of here. We can do a snapshot list. We can do a snapshot revert to added dash neofetch. It will restore the virtual machine. And now we log back in, and we should have neofetch back again because we restored the snapshot with neofetch. And sure enough, it works. We also have the ability to delete snapshots. So if we exit out and we do a snapshot list and we do a snapshot delete, on Ubuntu-test, and we get rid of the one with added neofetch, that snapshot will be deleted. And if we list the snapshots again, you can see that only the initial install snapshot is running. So if I removed the initial snapshot, or if I sign back in, and I should still have neofetch at this point because we haven't changed it, we just deleted the snapshot. If I can type, so there's neofetch, and if I list them out, and if I did a restore of initial install, you know that initial install doesn't have neofetch, so it would be gone. And likewise, the snapshot's gone, so I couldn't restore back to it again. So I'll remind you again that if we do a virsh list --all, we have the two other machines shut down, but our Ubuntu test is up and running. So if I do a virsh shutdown Ubuntu-test, and then if I list, I will see that all three machines are currently shut off. Now, in order to really delete a virtual machine completely, before we deleted the virtual machine, but we left the storage intact because we thought we might want to copy the storage file along with the backup YAML file that we created to another, or XML file that we created to another system to maybe move that VM. But in this case, now that the machine's shut down, I'm going to say undefine Ubuntu-test and remove all storage, which will make the entire virtual machine go away. So of course it says it cannot delete a machine with one active snapshot. Okay, so that's kind of interesting. So apparently we also have to be able to delete the snapshot before it will delete the machine. So if we do a list all, there's the machine, it's shut off. If we look at the snapshots, we would have to do a, let's see, snapshot delete Ubuntu test initial install. So of course the virtual machine is still in order, but it thought the snapshot was up and running, so that was sort of a problem. If we do a list again, there are no snapshots. Since there are no snapshots, I can go undefined and remove all storage, and this time it works and it removed the volume. So if I did an ls, well actually first of all, if I did a vir list all, you'll see that that test machine is gone. And then if I do an ls-al, well actually we'll have to do a sudo because that's a privileged location. If I do a sudo ls-al on /var/lib/libvirt/images, which is where all of the images for KVM disks are stored, you'll see that I only have my Ubuntu desktop and my Windows 11, but my Ubuntu test server is gone. So in summary, We reviewed how to create a network bridge on your KVM host, which is useful for Docker, LXD, and KVM. We created a KVM virtual machine using the virt-install command line tool. And we learned how to shut down and start up a KVM VM from the CLI. We showed how to delete a KVM VM. We learned how to make a backup of a KVM VM. And we learned how to manage snapshots for a KVM VM. KVM is an efficient virtual machine manager and a key part of a home lab configuration. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell.